So hello friend, this is Kausu Patare again with a new video. Welcome to our channel Making Maths Easy. So in the previous video I have told you some important concepts of the second order derivative, higher order derivative, how to calculate a higher order derivative, how to find d square y upon dx square. So today in this video we will solve some complicated sums based on higher order derivative. So let's start by solving the sums. So the first sum we have is x raised to x over here. So we have to differentiate it with respect to x. So let us consider first of all, let y be equal to the corresponding function. So the y equal to the corresponding function, then we have to differentiate it with respect to x. We have to double differentiate it, but first we have to find the dy by dx in this case. But before finding the dy by dx, let us know the type of the function. It is y is equal to x raised to x, as we are having the x parameter in the power function. So whenever there is a x parameter in the power function, and we are differentiating it with respect to x, or whenever there is a y parameter in the power function, then we are differentiating it with respect to y or x. So use log function. So first of all we will take the log on both sides. In these cases, in such cases, we have to take the log on both sides. So log y equal to log of x raised to x in this case. So we will use the logarithmic property, as the log of x raised to x, log of x raised to x is equal to x log of x in this case. So now we will differentiate it. So differentiating with respect to x in this case. So for differentiating it with respect to x, we will get the value of as follows. So first of all we will differentiate the log function, and then we will differentiate the y function, as we know that the derivative of y with respect to x, derivative of y with respect to x is dy by dx in this case. So we will differentiate it with respect to x. So log of y will be equal to 1 upon y dy by dx, 1 upon y dy by dx in such cases, because never forget to put the dy by dx, because dy by dx is the differentiation of y function in this case. And now we will put dy by dx of a derivative of d upon d of x of the corresponding function. Let's say the d upon d of x of x log x in this case. As per the property, we can replace log of x raised to x by x log x by taking the power in the frontwards. So now we will do it. So 1 upon y dy by dx will be equal to 1 upon y dy by dx is equal to x into the derivative, x into the derivative of log x, which we will use here the UV rule of differentiation. So x into the log x derivative plus log x into the derivative of x. So UV rule we are using over here, but we have to differentiate it once more. After differentiating it, we have to differentiate it once more, because here we have here it is asked to differentiate to taking the second order derivative of the corresponding function. So it will be derivative of log x will be 1 upon x. So x into 1 upon x, which gives me ultimately equal to 1, and log x into derivative of x, the derivative of x is equal to 1 only. So no need to write it, because derivative of x is equal to 1. So my dy by dx will be equal to, so the dy by dx, corresponding dy by dx will be equal to y multiplied by, this y has been multiplied in the numerator over here. So y multiplied by x multiplied by 1 by x gives me equal to 1. So y multiplied by 1 plus log x. So this is my dy by dx. Now we have to find the d square y upon dx square in this case. So for finding the d square y upon dx square, we need to square the function. We don't need to square the y, because y is a corresponding function. Only we have to find the derivative of second order in this case. No need to square the y. Only we have to square d square y upon dx square. You have to write in such format. So first of all, resubstitute the value of y, as y is equal to x raised to x. As I told you over here, y is equal to x raised to x in this case. So resubstitute the value of y, x raised to x, into the 1 plus log x, and then put this corresponding function and find the derivative of this corresponding function. So the derivative of this corresponding function will be equal to d upon d of x of the corresponding function. So here also we will use the UV rule in order to differentiate it. So I know that the derivative means dy by dx of x raised to x is this corresponding function. So I will take it. So first of all, this will be my u function, and this another function will be my v function. So u into the derivative of v plus v into derivative of u. So x raised to x into the d upon d of x of 1 plus log x in this case. So u into derivative of v plus v into the derivative of u in this case. Never forget to put the symbols while differentiating any function. So d upon d of x raised to x. As we know that the derivative of x raised to x, this derivative of x raised to x is equal to x raised to x 1 plus log x. So we can put it instead of taking the derivative of x raised to x and simplifying it. So we can put it. So we can write here as x raised to x, sorry, x raised to x into the derivative of 1 plus log x. So the derivative of 1 is equal to 0. So we can write over as 0. 0 plus log x. Derivative of log x will be equal to 1 upon x in this case. So 1 upon x. And then we have to write the derivative of 1 plus log x. So the derivative of 1 plus log x we have written over here, and then we have to write 1 plus log x as it is, because we are using the uv rule of differentiation. So we have taken the u into derivative of v. Also we have written the value of v, and we have to find the derivative of u. So the derivative of u is means x raised to x is x raised to x log x, which I have told you previously. So we will copy this and we will write over here. Okay, so now this corresponding function is equal to x raised to x uh, multiply by 1 by x plus this corresponding function. So we can write it as it is. This function we can write over here as uh, we can also simplify this function. We can also do one thing. It is here, it is x raised to x. We can write here as, sorry, we can write here as x raised to x over here, and x is in the denominator, so we can keep x as it is, and plus one thing, this 1 plus log x has been appeared two times over here, first time and second over here, so we can square it. So we can do one thing, we can write this 1 plus log x and we will use a square and square it, and then we will there is x raised to x, another term which we have to write over here, so we will write it. And we can do also, we can do one thing, we can take x raised to x as a common, and then we will do one thing, and which will be equal to 1 upon x, 1 upon x plus 1 plus log x the whole square. In this case 1 upon x plus 1 plus log x the whole square. So this is the final answer, or the final uh, d square y upon dx square, the second order derivative of the corresponding function. So let's start by solving the second sum. So this is our second sum. So we have to prove that we have to show that d square y upon dx square minus dy by dx minus 2 into x plus 1 into e raised to x is equal to 0. So we have the value of y is equal to x square into e raised to x. So first of all, write y equal to, we don't need to write the let y equal to, because they are given that y is equal to so and so function, so we don't need to write let y equal to so and so function. So first of all we will find the dy by dx, then we will find the d square y upon dx square, and then we will simplify the corresponding function. So let's find the dy by dx. So dy upon d of x of the corresponding function means derivative of y with respect to x will be equal to d upon d of x of the corresponding function x square into e raised to x. So first of all find dy by dx, so which will be equal to, uh, we will use the uv rule of differentiation in order to differentiate it. So u means x square into the derivative of e square e raised to x plus e raised to x into the derivative of x square in this case. So we will use the uv rule of differentiation in order to differentiate it. So the derivative of x square will be 2x, and derivative of e raised to x will be equal to e raised to x only. Note that the derivative and integration of e raised to x is e raised to x only. So which will be equal to, if it is e raised to 2x, it will be 2 into e raised to 2x, or derivative of e raised to 2x into 2 derivative of 2x. So let us consider this corresponding functions, and right here has x square as it is, and we have to take the derivative of e raised to x, also we have to take the derivative of x square according to the uv rule of differentiation. So x square into e raised to x also plus e raised to x into the derivative of x square, which is equal to 2x in this case. So now we have simplified. We can also write it as, we can take x as a common, so which we have x into the e raised to x, x as well as e raised to x we can take as common. So x e raised to x we have taken common, so we got here as x plus 2 in this case. Okay, so this is the corresponding derivative or dy by dx. So now we have to find d square y upon dx square. So double order derivative, second order derivative, we can say y double dash or f double dash of x. So now let's start with finding the double order derivative of the corresponding function. So the d square y upon dx square will be equal to d square y upon dx square will be equal to the derivative of this corresponding function, sorry, the derivative of this corresponding function. So we need to find again the derivative of this function, and then we have to substitute the values in the given equation, so in order to prove the corresponding function, so which will be equal to, so we can take now we have to use the UV rule of the differentiation. So this we will consider as u and this we will consider as v in this case. You can also do one thing, you cannot merge these things. If you are using the UV rule, there are three terms, because you can also use the UV rule of three term, but it will be lengthy. So you can do one thing, you can write this expression, no need to simplify the expression, and bring it in the smallest form like this. So you will write this corresponding expression and you will differentiate this function only, because this expression contains only two terms. So we will differentiate this function. So in this function we will use the UV rule, also in this function we will use the UV rule. So my dy by dx, put a bracket over here so it will be easy. So my dy by dx, we have to differentiate of first function, and then we have to differentiate the dy by dx of the second function in this case. So my dy by dx of x square plus e raised to x plus the dy by d d upon d of x of e raised to x into the 2x. So u into derivative of v, we have to use this derivative two times. So x square into the derivative, so we know that x square into the derivative of, means derivative, this we know, this part we know, because we can write over here a note that this is the first equation, and according to the first equation, the derivative of x square e raised to x is equal to x e raised to x into x plus 2. So instead of writing this or simplifying this complete expression, we have got the answer earlier over here. Okay, so x into e raised to x into x plus 2. So we can substitute from equation 1 over here, the dy by dx of x square into e raised to x is x e raised to x into x plus 2. So instead of this we can write this, so no need to simplify. So no need to simplify the function, only we have to simplify the function is that we have to simplify only this function. So find the derivative of this function. So d upon d of x of e raised to x, so put e raised to x. So first of all, find the derivative of 2x plus 2, take 2 as a common, and then e raised to x into the derivative of 2x, sorry, e raised to x into derivative of x plus x into derivative of e raised to x in this case. So in this way you have to apply the UV rule of differentiation and you have to get the answer. So which will be equal to this corresponding function, we have to write it as it is. This 2 is common in each case, so we have to write it as it is, and then the e raised to x into derivative of x. Derivative of x is equal to 1, so no need to write. So e raised to x plus x into the derivative of e raised to x over here. So the derivative of e raised to x, again it is e raised to x only, so we will write it e raised to x over here. And then we can also do one thing, we can take e raised to x as a common. So we have found out the d square y upon dx square, we have also found out the dy by dx. So we can conclude that this equation as equation number 2 in this case. So now we have to merge those equation, and we have to look the final means the given equation. We have to show that d square The given equation is d square y upon dx square minus dy upon dx minus 2x plus 1 e raised to x is equal to 0. We have to prove it. The given thing we have to prove it. So the given thing is this. So add put the values, put these values as this corresponding values. So d square y upon dx square we have to put. So first we will put d square y upon dx square, which is this equation number 2. Then minus it. So use the minus subtract symbol, and then we have to put dy by dx. So minus dy by dx. So my dy by dx is equal to this equation number 1. Okay, so x into e raised to x into x plus x plus 2. So again we have to put the minus sign, and then we have to put this 2 into x plus 1 e raised to x. So let us consider, let us find that this corresponding value be equal to x or not, be equal to 0 or not. So which will be equal to, this corresponding value will be equal to, first of all merge this all the terms. So you will get the term as equal to x square, sorry, you will get the term equal to x square. So write x square over here, x square e raised to x, x square e raised to x into the x e raised to x into 2, means which will be equal to x e raised to x. So plus 2 into x e raised to x plus 2 into e raised to x right over here. Okay, plus 2 into x e raised to x. So write again x e raised to x. So now here it is a minus sign. So we will write here as x e raised to x into x gives me x square e raised to x. So I will write over here as x square e raised to x minus 2 into x e raised to x. Again I will write x e raised to x. So, and again I am having the minus sign over here, so it will be 2x, x is over here and e raised to x is over here outside. So 2 x e raised to x again, and then I am having minus 2, so minus 2 e raised to x over here as outside, so I will write over here as outside. So the terms which are cancelled in this case will be this will get cancelled, so no need to write this, cancel this, as well as I will cancel this term. So again I will do one thing, I will also cancel this term, and this is also minus, so I will also cancel this term. And then one thing I will do, I will also cancel this term, and I will also cancel this corresponding term, because they are minuses of each other. So the last term which are remaining are 2x into e raised to x minus 2x into e raised to x, which is ultimately equal to 0. So hence we have proved that the corresponding given expression d square y upon dx square minus dy by dx minus 2 into x plus 1 into e raised to x is equal to 0. So hence we have proved the corresponding function. Always try to do the sums in the step by step manner, because each and every step carries the marks. So if you like the video, please share, subscribe and comment on my YouTube channel Making Maths Easy for more videos related to mathematics, derivatives, integration, Pythagoras theorem and all other any engineering subjects. Please subscribe my channel. I will also add the videos on the engineering mathematics soon. So thank you for watching. Thank you guys.